Hi everyone, my name is Samantha and I'm a senior currently at USC. I teach with USC's YSP Young Scientists Program and I typically teach third grade at 32nd Street Magnet School. And today we're going to learn a little bit more about fossils.
Okay, so first, what are fossils? So fossils are the remains or traces of plants and animals, otherwise known as living things, that lived long ago. So they give scientists clues about the past, and a scientist that studies fossils is called a paleontologist. So fossils are usually coming from the hard parts of living things, so like bones or shells that stay years and years and years later. Alright, so here we'll talk about the four main types of fossils, but in reality, these types branch out from the two main types of fossils. So the first type is called a trace fossil, which is evidence of biological or living activity. So it doesn't have to be part of the living animal. And then we have body fossils, which is the fossil that we're most familiar with. So it includes like bones and teeth and shells are all examples of body fossils. Okay, so now for these four main types, first we have the trace fossil, which gives evidence of activity and behavior. So a good example of a trace fossil is like a footprint, because the animal leaves it behind and it tells us things like where the animal's going. And then we have a mold fossil, in which you can think about like a cupcake mold or a jello mold. And basically it's like a hole or an imprint that the animal left there, so we can see the shape of the animal. And then there are cast fossils, which is basically like a mold. So again, you can think of like the jello container. And if you fill it with something like jello and then you pop the jello out, the jello is going to have the same shape. So that's a cast fossil. It's taking the shape of the mold. So it's 3D. And then finally, we have true form fossils, which is over here. And this includes the actual animal or plant. So the actual animal or plant is stuck within this fossil, often in resin. So like here's a spider that is stuck in a piece of resin or sap. If you need the slides in Spanish, here it is. Alright, so how is a fossil actually made? So first we start off with like our little fish living in his habitat. And eventually the fish dies and he sinks to the sea floor. So he sinks all the way to the bottom. And then the soft parts, like his skin and his organs, are decaying. So they just like kind of fall apart. And then the fish is covered under sediment, which is a thin, very fine type of dirt. And then over time, the sediment turns into hard rock. And then the rock is distorted and uplifted. So this can happen like from an earthquake, or maybe the lake dried out. And then finally, a scientist comes along and recognizes it, says, that's a fossil, and extracts it. And finally finds that the fish skeleton is preserved in a rock, it's hard now, as a fossil. So fossils help provide evidence or clues of prehistoric things. That's pretty cool. Fossils tell us stories about Earth's history, but still, paleontology is packed with mysteries. Think about what this fossil can tell you. And everyone, here's Mary Anning. This is our paleontologist of the day, and she's super cool because she helped discover the Ichthyosaurus, or the fish lizard, which was part marine or aquatic and reptile. So it was a marine reptile. And what's extra cool is that she was one of the first female scientists or paleontologists during a time when mostly men were scientists. She was also the inspiration for the tongue twister, "She sells seashells by the seashore." Alright, now it's your turn to be a paleontologist. Let's get started.
A simple way to play with fossils is to use some dough, like clay or play-doh, and some little toys like these tiny dinosaurs. And here I'm just flattening out the dough. And doing the same with the orange one. And now I'm pressing each of the dinosaurs into the respective play-doh. Let's put one in each. and carefully pull them out. And now take a look at the imprints, or the fossils that were left behind, and see if you can tell which dinosaur is which and why you can tell them apart. Awesome! Great job today, scientists! See you next time!